to see the unseen, to know the unknown, to set forth in search of knowledge, this has been the goal of man since the beginning of time. In this land of Farsha, the eternal quest of the philosopher has been to discover the unity that lies behind diversity. How this goal, perceived intuitively by our ancestors, illumined the mind of an Indian scientist, forms the life story of Jagadish Chandra Bose. The excavations of Mohenjo-daro are testimony that India had made striking advances in science thousands of years ago. It was our ancestors who invented the decimal system of notation. And in their time, the branches of mathematics, among them arithmetic, algebra, and geometry, were already well developed. Among the greatest advances in mathematics were the decimal system of notation and the invention of the unit zero. They contributed to the rapid progress of scientific knowledge. Our scholars of old, speculating on the composition and properties of matter, were the first to establish the theory and pattern of atomics. There followed the age of the alchemists. Though the apparatus they used was simple enough, the results they achieved were often remarkable. They discovered the secrets of making glass and how to extract gold and silver in highly purified forms. They discovered the formulas for making acids, alkalis, drugs, and medicines. But more important than all these was their art of making iron and steel. In the 4th century AD, they forged the wrought iron pillar which stands near the Qutb Minar in Delhi. It is a glorious monument to the skill and knowledge of our early metallurgists. The name of our own Nagarjun finds a hallowed place among the immortals. Generation follows generation, and the search for knowledge continues. The lamp of learning, kindled by our ancestors many thousands of years ago, now illuminates the darkness of distant lands from Nalanda, a great university founded some 1,500 years ago. Countless students of our own as well as those of other countries came to study here. For Nalanda was indeed an international university. It was here that teachers of the caliber of Shilabhadra encouraged scientific study as well as in other fields. Scholars, students, and pilgrims crossed the mighty Himalayas or braved the dangers of the deep to drink at this fount of knowledge. Thus India attained prominence in the world for her scientific knowledge, no less than for her religious wisdom. And in the course of centuries, India's high standard of civilization was disrupted by invasions through our northwestern borders. Though these were tempestuous times, our scientists, architects, and engineers continued to create and construct. And the evidence of their skill can be seen even to this day in Konark, Jantar Mantar, and the Taj Mahal. Meanwhile, West Asia and Europe made momentous progress along the paths of science. Galileo invents the telescope. Newton follows Galileo to introduce a new law of physics. Lavoisier and Dalton make their remarkable contributions to chemistry. Volta and Galvani begin the study of current electricity. It was not long before India joined the other nations in furthering the cause of modern science. Who then in India furthered the cause? To find one answer, we must turn back to the later years of the 19th century, to Bengal, where we find our seeker after truth, Jagadish Chandra Bose. Jagadish Chandra's father was Bhagavan Chandra Bose, deputy magistrate of Faridpur. He was a fearless champion of the town and the numerous neighboring villages. Father, why are there waves in the river? They are caused by the wind, my son. I threw a stone into the pond and it made the same waves. Why, Father? Do you know, Father, the flowers whisper and dance and sing? Why? Why? Son, I do not know. There are many things I do not know. Grow up and find the answers. Often as evening fell, Jagadish Chandra would be a silent listener to tales of mystery told by the old caretaker who was once a dacoit. The criminal had been sent to prison by the judge, but on his release, Bhagavan Chandra had tempered justice with mercy by employing him as an escort for his son. What are you up to? He's telling me a story, Father. You can listen another time. Come along now to the Jatragan. I've arranged for our villagers.
সাধু হে অর্জুন অপূর্ব তোমার সরসন্ধান এই আপনারই আশীর্বাদ দেব অর্জুন ব্যতীত এই রূপ সরসন্ধান করতে আর কে পারে আমি পারি
Of all the characters in the great Indian epic, the Mahabharata, Karna was the young boy's hero. As a stranger from Karna to challenge Arjuna, and when questioned as to his name and birth, he replied, "My own father am I. Would you dare ask of the mighty Ganga which of your many rivulets is your mother? Her flowing waters are her own testimony. Likewise my deeds become me." These stirring words echo in his ears throughout his life, and Karna became his source of When the time came for Jagadish Chandra to attend school, his father sent him to the village Pathshala instead of an English institution. For his father believed that first a child must know well his own mother tongue and his own people before mastering English. From his classmates, the sons of farmers and fisherfolk, Jagadish Chandra learnt many things, and because they lived close to nature, its many wonders were revealed to his imaginative mind. Day follows day, each a wave on the journey to eternity. Now it was time for him to learn English, and he was sent to St. Xavier's School in Calcutta. He soon learnt that it was better to give than receive. At home he spent his free time designing a miniature garden through which flowed a stream of his creation laced by little bridges. Here was evidence of that orderliness of mind which bespoke the future scientist. Even as a little stream, fed by the waters of the valley through which it flows, grows into a great river, so Jagadish Chandra grew to manhood, drawing strength and wisdom from the experiences of those early years. Soon after receiving his Bachelor of Arts from St. Xavier's, he set sail for London. Since his father had left him nothing, Jagadish Chandra could not afford to pay for his passage to England. However, his mother came to his rescue by offering him her entire savings, for she had full faith in her son and dreamt of the day he would return to his native land with far greater rewards. Cambridge University, the shrine of science. The home of Erasmus, Milton, Newton, Darwin, Clerk Maxwell, and other champions of freedom of thought against privilege. Students the world over foregathered here in the name of science. And one day, Christ College welcomed Jagadish Chandra. In London, he first took to medicine, but poor health forced him to give it up. He was filled with rare emotion as he walked where the pioneers of the past had walked before him. Their patience and perseverance had kindled the flame of truth to help dispel the shadows of ignorance and superstition. He was determined to follow in their footsteps and deck Mother India with the ornaments of newfound knowledge. His days at Cambridge were full though fleeting. Under the careful guidance of Lord Raleigh, he found physics of absorbing interest. He also studied botany and physiology under Professor Vine, Francis Darwin, and Michael Foster. His diligence was rewarded. He obtained his BA from Cambridge and the BSc from London University. And then it was time for him to return to India. He took his leave of Cambridge with regret, for his mind was full of happy memories of the university and of his associations with its great scholars and teachers. These memories he treasured all his life. And as he sailed for the shores of India, his inner voice kept prompting him. There is so much to be done, and so little time to do it in. Presidency College, Calcutta, where Jagadish Chandra was appointed as a junior professor in physics. For 9 years, he devoted himself to teaching science. He built a laboratory and conducted a course of experiments for the benefit of his students. But across the years, the inner voice continued to haunt him. So much to do, and so little time to do it in. In 1887, he married Kumari Abla Das, who was his life partner for 50 years, sharing his ideals, his joys, his sorrows. During vacations, they visited renowned places such as Kedarnath or Badrinath in the Himalayas, and those which were of historical or archaeological interest. By these tours, he broadened his knowledge of his motherland. This letter, written after one of his tours, gives us an idea of the course his future was to follow. On the 30th November 1894, his 34th birthday, he decided to devote himself to the pursuit of new knowledge. Since his Cambridge days, he had been interested in the work of Maxwell and the electromagnetic theory of light. Now he devoted his time to that branch of physics. His first experiments were with electromagnetic radiations. When a charged condenser like the Leyden jar is discharged, electromagnetic waves are propagated through the ether. These waves have the same properties as light waves, which was what Maxwell had predicted about a century ago. The German scientist Hertz devised an apparatus to prove Maxwell's theory. Hertz obtained only the longer wavelengths, and his results could only be demonstrated with the use of very large apparatus. By considerably modifying Hertz's apparatus and setting up one that was far more compact, Jagadish Chandra obtained short waves 5 millimeters in length for the first time in the world. His components, like the polarizer, prism, and induction coil, were far smaller than those designed by Hertz. His apparatus consisted of a detector known as a coherer, which he called the electric eye, a galvanometer which he referred to as the brain, and the connecting wires which were the optic nerves. Such names give us a glimpse of his potential interest in biology. With this apparatus, he proved that electromagnetic and light waves conform to the same laws of reflection, refraction, polarization, and so on. Radio, radar, and television, which use wavelengths ranging from 400 meters to a centimeter, have come into being thanks to the pioneering efforts of men like Jagadish Chandra. He modified his coherer even further to produce minute electric waves that could be transmitted without the use of wires. And this posed a problem that intrigued him. If light waves can travel without the help of wires, why not electric waves? For their properties are the same. He proved the point of his arguments in 1895. He used an electric wave generator to fire a gun placed 75 feet away, even though the two were not connected by any wire. The results of this unique experiment were of profound interest to men like Marconi, Lodge, and Muirhead, who were also attempting to transmit wireless messages. While working with his detector, Jagadish Chandra observed that after every charge of electricity, certain metal parts suffered from fatigue. To recover from fatigue, the metals needed rest or subsequent tapping. By deciding to investigate the cause and amount of metal fatigue, he now concentrated on the responses of inorganic matter. He invented a new detector called an artificial eye to detect light and electrical responses. This eye is the forerunner of the modern photocell, which plays a vital part in radio, cineprojection, sound recording, and television. He not only designed but made every one of his super-sensitive apparatuses himself. Lacking a workshop, he engaged a humble tinsmith to help him with construction. In 1896, he was sent on a deputation to Europe. He gave lectures and demonstrations in England and in Europe. Many men of business approached him for the patent rights of his newly devised detector for commercial exploitation. Jagadish Chandra declined, saying, "Science is not for sale." (1900), the International Science Congress, Paris. Eminent scientists of the world are gathered here. Jagadish Chandra represents India and delivers a lecture. Present in the audience is the great Swami Vivekananda, who says, "Here in Paris have assembled the great of every land, each to proclaim the glory of his country. Among these peerless men, gathered from all parts of the world, where is thy representative, O thou, the country of my birth? Out of this vast assembly, a young man stood for thee, whose words have electrified the audience and will thrill all his countrymen." Soon Jagadish Chandra's name was heard from the Volga to the Ganga, from the Mississippi to the Yangtze. But even now he was haunted by the voice from within. So much to do, and so little time to do it in. 1901, the Royal Institution, London. He gave a lecture demonstration of his latest experiment, the response of inorganic matter to chemical and electrical stimulus. He demonstrated that non-organic matter, such as metal, responds in the same way as living matter. He took a frog muscle, a plant, and a piece of metal, tin. He showed that all of them exhibit fatigue under continuous stimulation, enhancement of response under chemical stimulants, and cessation of response under poisons. He ended his lecture by saying, "I have shown you this evening similarity in the living and the non-living. Amongst such phenomena, how can we draw the line of demarcation and say, here the physical ends and there the physiological begins?" It was when I came upon the mute witness of these self-made records that I understood for the first time a little of the message proclaimed by my ancestors on the banks of the Ganga thousands of years ago. They who see but one in all the manifold changes of this universe, unto them belongs the eternal truth, unto none else, unto none else. Of this unique discovery, his lifelong friend, the poet Tagore, wrote, "Whence hast thou that peace in which thou in an instant stoodst alone, and at the deep center of all things? Where dwells the one alone in the sun, moon, flowers, in leaves and beast and birds, and dust and stones, where still one sleepless life on its own lap rocks all things with a wordless melody, all things that move or that seem motionless." Looking at the world of plants, Jagadish Chandra said, "As we go out into the open, an exuberance of life attracts us on all sides. That life is utterly silent. The winter and the summer, the air and the wind, the rains and drought, the light of day and the dark of night, all are sporting with this life that continues speechless around us." He made a series of experiments to prove the similarity of animal and plant life, and that the vital activity or energy, whether in animal or plant, is derived from solar radiation. The plant absorbs solar energy and carbon dioxide and builds up organic matter charged with latent energy. The animal derives its energy from vegetable matter. Hydrilla, a water plant, absorbs the carbon dioxide dissolved in water and evolves an equal quantity of oxygen. This oxygen accumulates in the U-tube and lifts the mercury valve at a certain pressure. Each lifting of the mercury valve completes an electric circuit, and it is automatically recorded as dots on a moving drum while a bell is rung. With the increase in light, the bell rings in quick succession, and the dots are recorded at shorter intervals. When the light decreases, the bell rings after a longer interval. The effects of nutrition are shown by the growth of the plant. Jagadish Chandra designed a highly sensitive apparatus called a double-lever crescograph to study the growth of a plant. By this apparatus, a magnification of 10,000 times was possible. He also designed another apparatus called a magnetic crescograph, which could magnify 1,000,000 times. Plant growth cannot be seen by the naked eye, but it can be seen by the crescograph. When a gentle stimulus is applied to the plant, its growth is accelerated. When the stimulus is great, the organ contracts and growth is retarded. Plants also exhibit rhythmic movements similar to those in an animal's heart. In some plants, the pulsations can be visually observed, while in others, it can be detected only through electrical devices. Pulsations are most conspicuous in the lateral leaflets of the Desmodium gyrans. They are being automatically recorded by this camera. A tiny leaf is attached to a recording glass lever by a fine silken thread with a touch of shellac. The upward and downward movements are recorded on this smoked glass plate. Similar curves are obtained by recording the movements of a frog's heart. When poison is dropped on a leaf, the plant gives a death cry, and its pulsatory movement stops. Excitation, brought about by a stimulus applied at a point on the plant, is transmitted to other parts of the plant. The same thing occurs in an animal's body. When a child puts his finger in a flame, before he has time to cry out, the arm is automatically withdrawn. This is because an ingoing strong stimulus reaching a nerve center is reflected into an outgoing impulse through a new path, causing the hand's withdrawal. A similar reflex arrangement has been discovered in the mimosa plant. The excitation due to a stimulus applied at one end of the leaf first reaches the main palvinus and then is reflected back to the other leaves. With this apparatus, Jagadish Chandra determined the speed of transmission of excitation through plant tissue. The transmission of excitation of the mimosa plant is recorded on smoked glass by a vibrating lever. Observing the world of plants, he used to say, "They are our mute comrades whose life runs its silent course. They record their reactions without sound, but our eyes can see the stirrings of their life and the pangs of their death." The greatest day in his life was the 30th November 1917, when the Bose Institute was opened in Calcutta. Every corner of the institute echoed to the song specially composed by Tagore for the opening ceremony. Even today, the institute bears the dedicatory inscription, "I dedicate this institute to God, for the glory of India and for the welfare of all mankind." The Amlaki emblem of the Emperor Ashoka figures at the cornices of the institute. It is a symbol of sacrifice, and towering above all else is the symbol of the thunderbolt. It was the Rishi Dadichi who gave his life so that the divine weapon, the thunderbolt, might be made from his bones to smite evil and exalt righteousness. Today, the walls and pillars of the lecture hall are mute witness to Jagadish Chandra's dedicatory speech made at the opening ceremony. He said, "The advancement in science is the principal object of this institute, and also the diffusion of knowledge. This is not merely a research institute, this is a temple." We stand here today and resume work tomorrow, so that by the efforts of our lives and our unshaken faith in the future, we may all help to build the greater India that is yet to be. I am attempting to carry out the traditions of my country, which as far back as 25 centuries ago welcomed all scholars from different parts of the world within the seats of learning in Nalanda and Taxila. To build this temple of knowledge, he gave all his life's earnings. For 18 years, under his guidance, scientific investigation was carried on. Many unknown phenomena came to light here for the first time, and the Bose Institute won worldwide recognition. And in the course of time, he was elected as Fellow of the Royal Society of Britain. Jagadish Chandra's contributions to Bengali literature were many and varied, and his book, Abhakta, a collection of essays, are the creations of a sensitive mind. He has won a rightful place in the halls of science, but in the coming years his versatile activities will also be equally honored in the domain of art and culture. 1937, he rests a while at Giridih. On the 22nd of November, he discusses with his wife and secretary a proposal to donate all of his personal funds to various institutions for the cause of social welfare. On the following day, and soon the news is flashed around the world that Jagadish Chandra is no more. Countless friends, admirers, and disciples, with tearful eyes, are present at his cremation. His ashes are enshrined in the grounds of the Institute. His wife, Abula Bose, donates his entire wealth and savings to charity, for that was his final wish the day before he died. Acharya Jagadish Chandra used to say, "I came with nothing, and with nothing I return. But if I accomplish something in between, that will indeed be a privilege." Though more than 20 years have passed since he departed, time cannot erase the value of his work or his example, for he is the heart of the true scientist of today and of tomorrow. And echoing across the chasm of the years, even across the high Himalayas, are the words he spoke to guide us anew. Not in matter, but in thought. Not in possessions, nor even in attainments, but in ideals is to be found the seed of immortality. Not through material acquisition, but in generous diffusion of ideas and ideals can the truth of humanity be established.